Welcome to Error Handling in Python. Errors are inevitable in programming. But how you handle them makes the difference between robust, professional code and programs that crash unexpectedly. Today we'll master try except finally blocks to write resilient applications that gracefully handle unexpected situations. Without error handling, a single unexpected input or situation can crash your entire program. Users see cryptic error messages. Data might be lost, and your application appears unreliable. Error handling lets you anticipate problems and respond appropriately. Here's the difference. The first example crashes when given 0 as the divisor. Users see a technical error message they don't understand. The second example catches the error and provides a user-friendly message. The program continues running normally, maintaining a professional user experience. The try except block is Python's fundamental error handling mechanism. Code that might cause an error goes in the try block. If an error occurs, Python jumps to the except block instead of crashing. Let's see how this works step by step. Here's the execution flow. Python first tries to execute the code in the try block. If no error occurs, it skips the except block and continues normally. If an error does occur, Python immediately jumps to the except block to handle it, then continues with the rest of the program. This prevents crashes and allows graceful error recovery. Let's look at the basic syntax and see a practical example. The try block contains code that might cause an error. The except block specifies what error to catch and how to handle it. You can be specific about error types or catch all errors. The syntax is straightforward. The try keyword starts the protected block, followed by the code that might fail. The except keyword catches specific error types. In our practical example, we handle value error when converting user input to an integer. If the user enters text instead of a number, we catch the error and provide a friendly message instead of crashing. Python has many built-in exception types for different error situations. Knowing the common ones helps you write more specific error handling. Let's explore the most frequently encountered exceptions and when they occur. Here are the most common exception types. Value error occurs when trying to convert invalid data, like text to integer. Zero division error happens with division by zero. File not found error occurs when accessing missing files. Index error happens when accessing list indices that don't exist. Key error occurs when accessing dictionary keys that aren't present. Each has specific use cases and handling strategies. Important tip: Python checks except blocks in order. So put specific exception types first, then more general ones. This ensures proper error handling and prevents specific exceptions from being caught by generic handlers. You can handle different types of errors differently using multiple except blocks. This allows for tailored error messages and recovery strategies based on the specific problem that occurred. Let's see how to structure multiple exception handlers. This example shows multiple except blocks handling different error types. Value error catches invalid input conversions. Zero division error handles division by zero. Index error catches invalid list access. The final exception block catches any unexpected errors. Each provides a specific, helpful message for that error type. The execution flow checks each except block in order. Python uses the first matching exception type and skips the rest. This allows precise error handling, with appropriate responses for each situation. The general exception catch all should always come last. The finally block contains code that runs no matter what happens, whether the try block succeeds, fails, or even if the program is interrupted. This is perfect for cleanup operations like closing files, releasing resources, or logging completion. Here are 3 scenarios showing finally's behavior. In success, try executes then finally runs. With exceptions, try fails, except handles it, then finally runs. Even if interrupted, finally still executes for cleanup. This guarantees that important cleanup code like closing files always happens. This file handling example shows finally in action. Whether the file opens successfully, fails with file not found error, or encounters any other issue. The finally block ensures the file gets closed properly. This prevents resource leaks and maintains system stability. The else block is Python's lesser-known error handling feature. It runs only when the try block completes successfully without any exceptions. This is perfect for code that should only run when everything goes right. The complete try except structure includes all blocks. The else block only executes when the try block succeeds completely. This is useful for success-specific actions like saving data, sending confirmations, or logging successful operations. Finally always runs for cleanup regardless of what happened. In this example, the else block only runs when user input is valid. It welcomes the user and saves their data to the database. If there's an input error, the except block handles it and the else block is skipped. The finally block always logs that the session is complete. Let's see error handling in a real-world scenario. File operations. Files can be missing, locked, corrupted, or permissions might be denied. Good error handling makes your file operations robust and user-friendly. This comprehensive example handles multiple file-related errors. File not found error for missing files. Permission error for access issues. Value error for invalid data format. And a general exception for unexpected problems. The else block runs success logic only when everything works. Finally logs completion regardless of outcome. Let's cover essential best practices for error handling. Following these guidelines will make your error handling more effective, maintainable, and user-friendly. Here are the key best practices. Be specific about which exceptions you catch rather than using generic exception handlers. Always provide helpful error messages that guide users toward solutions. Log errors with sufficient detail for debugging. Never ignore errors with empty except blocks. This hides problems and makes debugging nearly impossible. Sometimes built-in exceptions don't fit your specific needs. Python lets you create custom exception classes for domain-specific errors. This makes your code more expressive and allows precise error handling for business logic. Custom exceptions make your code more expressive and professional. Here we define insufficient funds error with custom logic that stores both the current balance and requested amount. This provides detailed error information. Custom exceptions inherit from the exception class and can include additional data and methods as needed. Exception objects contain valuable debugging information. You can access error messages, exception types, and even stack traces to understand exactly what went wrong and where. This information is crucial for effective debugging. This example shows how to extract detailed exception information. We get the exception type name, the error message, and the line number where it occurred. The traceback module provides full stack traces for debugging. In production, log this information rather than printing it to users. This data is invaluable for identifying and fixing issues in your applications. Exception handling has performance implications. Try except blocks have minimal overhead when no exceptions occur. But catching and handling exceptions is expensive. Design your code to avoid exceptions in normal operation. Here are key performance considerations. Use exceptions for truly exceptional situations. Not normal program flow. Validate inputs upfront to prevent exceptions. Check if dictionary keys exist rather than catching key error. Use conditional statements for expected scenarios. The fast example avoids the exception overhead by checking the condition first. Let's summarize our journey through Python error handling. Try except blocks are your primary tool for preventing crashes and handling unexpected situations. Gracefully. Use specific exception types rather than generic catches. Finally, blocks ensure cleanup happens regardless of success or failure. Else blocks run success-specific code. Custom exceptions make your code more professional and expressive. The key takeaway is that good error handling distinguishes amateur code from professional software. Users don't remember perfect functionality as much as they remember how gracefully your program handled problems. Robust error handling builds user confidence and makes your applications production ready. Always log errors with sufficient detail and provide helpful user messages. Let's conclude with a complete example that demonstrates all the concepts we've covered. This function safely processes user data with comprehensive error handling, logging, and user-friendly responses. First, we import the required modules. Logging is configured at the info level, and we create a logger for structured error tracking. We define our main function. It accepts a dictionary of user data and returns either a user ID if successful, or none if registration fails. Inside a try block, we validate the required fields: name, email, and age. We also ensure that age is between 13 and 120. Raising value error if the data is invalid. Next, we simulate saving the user to a database and sending a welcome email. If these succeed, the flow continues. We then handle errors. Value errors for bad input, connection errors for database failures, and a generic exception for unexpected issues. Each is logged with the right severity and a helpful user message. If registration succeeds, the else block runs and confirms the account creation. The finally block always logs completion. We also define helper functions for database save and email sending. Finally, we test with a sample user, showing a full registration flow. Congratulations on mastering Python error handling. You now have the tools to create robust, professional applications that handle unexpected situations gracefully. Remember, error handling isn't just about preventing crashes, it's about building user confidence and creating software that people can rely on. Practice these techniques in your projects, and always think about what could go wrong and how to handle it elegantly. Happy coding! Now go forth and build bulletproof Python applications with confidence, knowing you can handle any error that comes your way.